Hey folks, Rob from EdgeBit here. Today I want to give you a tour of the EdgeBit security platform, both as a software engineer and a security engineer. So let's jump in. Here you can see I'm inside of a pull request and I just added some functionality to add IAM integration to my platform. So I had to bump some OIDC libraries and the base image, and I put this pull request up, and then boom, you can see that the EdgeBit bot has commented with some security context. I've got some new dependency risks in libxml2 and libtiff6, modified some of those versions, and they've got high vulnerabilities inside of it. Now I've also just made some other additional changes with no risks. Some Go modules were added, and then I upgraded an existing Go module as well. So I've got all that context right here to jump in and do some more research. Now, of course, I can jump over to the EdgeBit app itself and then get a little bit more context. And so let's go ahead and do that right now and jump to our platform backend. Here you can see an overview of this platform backend. We got labels and other organizational details with the source repository for it, some SLAs. I don't currently have those set. And then you've got our vulnerability trend. And you can see that we had a big drop. That's because we updated some of our issues to fix the things that we found in that pull request. At the bottom here, you can see that we've generated a software bill of materials for the pull request that we just opened. And this is tied to a running workload. In this case, we've got 2 copies of it running. And then we've also got some retired builds here. These are containers that are not running in our infrastructure. And now let's jump over to our vulnerabilities. And this is where we saw some of the same information that we got from our EdgeBit bot with a lot more context. And so our suppressions here, we actually have 80 vulnerabilities that were just suppressed by our threshold policy. That's like, I don't care about negligibles right now, as well as 17 vulnerabilities that were suppressed for being dormant. So that saved us about 14 hours of triage, and that really means that we're actually doing manual kind of investigation for only 2% of our vulnerabilities, which is really, really great. When we scroll down here, you can see a list of all of our issues. Here's our libxml2. It's fixed, and we can upgrade that to this version to fix it. And you can also see that it was suppressed due to our policy. So we actually dropped this from a high to a low because this code does not actually run inside of our application. It's not a risk to us. And so this null pointer that is the problem here, that's never going to happen to us. And if that does, then we will change that severity rating. You can see we've got a number of other lows here. Let's jump over to our resolved. Here you can see a bunch of criticals that we actually fixed a number of weeks ago, and that caused our big drop off there. And we can have this for tracking SLAs over time, as well as go look at the ignored ones. These are those negligibles that I mentioned earlier. These are things that just don't need to pop up on our radar. All right, let's switch personas here, and now I'm on the security team. I care about everything running across the infrastructure, and I need to look after all of our threats. And so here you can see active dependencies. We've got 8,000 some packages, of which 1,600, or about 20%, are in use across all of our workloads. And our actionable vulnerabilities, we've got 200 out of about 1,800 exist and have a fix available. And so that is only 15%. That seems much more manageable than looking at every single one of them. You can see a list. It's Java archives, RPM, some Python packages, some Go libraries, etc. And so we're only looking at highs and criticals here, and we can take a look at the individual CVEs inside of each one of those and start knocking them down one by one. Let's jump over to an individual machine and look at how the workload correlation works. So here we get a bunch of metadata about the machine itself, some labels for grouping. We've got the machine operating system is Amazon Linux 2. And we also have a breakdown of the active and dormant dependencies. In this case, we've got 500 out of 1,900, and that's about 28%. And then the CVEs that are also correlated to them, about 101 for this specific machine combo. And we're running log4j, so that's kind of expected. And if we open this up here, you can see a catalog of all the active packages. It's the log4j and all the things that you would expect here. And below that is the operating system itself. And so these are all the packages and things that are active on that OS, and only active packages that have actionable CVEs. And we can see an example of that in the containerd package here. We've got 3 CVEs. They all have a fixed version, so we could upgrade that or upgrade the OS. And we know it's running because this containerd process is actually loaded into memory in the kernel. And if we scroll down, let's take a look at another one here. Let's take a look at Open LDAP. So we can see that we've got 2 CVEs, and this shared object is actually loaded by the kernel. And so we are at risk for these 2 CVEs. And they have a fixed version, again, that we could go upgrade to manually if this risk was high enough. before Amazon Linux updates them. It's a really quick overview of the EdgeBit security platform. What we saw is a pull request, getting some security context right inside that for the engineer, as well as tracking that build, making a software bill of materials that correspond to all of the dependencies inside of that, mapping those to vulnerabilities, and then tracking that workload as it goes all the way through all of systems, all the way to production. And then we took a look at an individual machine, and you can see the combo of both the security content in containers and the operating system and how that forms a unique pair of what our security risk is. So if you'd like to learn more, please visit us at edgebit.io. We'd love to pair you with an engineer, talk about your supply chain concerns, how you run vulnerability management, and we think we can supercharge it by ignoring a lot of this stuff that doesn't matter and focus on the real investigation.